Let's begin with the class. To review, let us discuss about this question. Yeah, number 19. Any idea? Can we express any matrix as the sum of symmetric and anti-symmetric matrix? Can we do that?
Anti-symmetric.
Not symmetric.
Is the element still the same? Or
Feeling false.
kayak false.
Identity symmetric.
Identity is symmetric.
Symmetric.
True ya.
Any matrix can be expressed as the sum of symmetric and anti-symmetric.
Itu false karena permainan kata sama.
Yeah.
Kayaknya false.
This is false because it will be too constraining for a matrix. Okay. Very constraining. Let's say diagonal matrix. Can you express a diagonal matrix as summation of symmetric and anti-symmetric? One must be anti-symmetric. It's difficult.
Sir, what is an example of anti-symmetric matrix?
Anti-symmetric means it is not symmetric. Okay, just that one. Okay. The second one. Is it true that AB transpose is equal to A transpose B transpose? Yeah.
No.
This problem. Yeah. The answer is false. This problem only is telling you that if you have a product and then you transpose it, then it becomes like this. Okay. So the second matrix becomes the first one when you transpose it.
Salah ya, false.
So it's false. What about this one?
The product of two symmetric matrices again symmetric.
Yes.
No.
Product of two symmetric.
Produk tuh maksudnya apa?
No, inverse is different. Inverse is different.
Kali atau ditambah. Bentuknya nanti tetap symmetric.
Yeah. So Jonathan asked me that is it true that if we have this, is it this one? No. We cannot make that relationship.
Dia
Yeah.
nggak mungkin
Transpose
kebalik ya kalau kayak gitu.
For transpose, this is correct, but for inverse, this is not.
Oh, no.
Number 21. Is it true? Anyone? True or false?
True.
So let us see this. Yeah. Let's say A is symmetric, B is symmetric. So A is equal to A transpose, yeah, symmetric. And then B also equal to B transpose because A and B symmetric. Now let us multiply A and B. Multiply A and B. A and B. This is the product, yeah. So if A, B symmetric, then its transpose must be the same with
B transpose.
A transpose, yeah. So that means this must be equal to B times A. Yeah. Is this true? For any matrix, yeah, AB is not necessarily the same with B times A.
Yeah.
So this is false.
Number 20.
Number 21 is false. Yeah, 21 is false. It's definitely because of this reason. Yeah, it's not always the same. AB times BA. For scalar, this is true, but matrix no. Not true.
Oh, maksudnya ini kalau kita kalinya AB dengan BC gitu. BA.
Number 22.
What the conversion power 5
Is it true?
Lower 3 is the lower. Diagonal lah.
Yep.
Bentar.
Radit says true. Any voice from there?
I don't think it's
Enggak,
true.
enggak.
You don't think it's
Triangle
true?
berarti cuma ada yang di bawah kan? Kali ini sebenarnya. Kali.
Yeah, it's a good idea to open MATLAB now. You want to check all the things. Michael, any idea? 22?
True, identity.
Okay, let me ask you. Identity matrix. Is this diagonal? Okay, identity diagonal, yeah. What if we multiply diagonal matrix with a matrix A? What do we have? Matrix A. If A is lower triangular,
Lower triangle.
this is also lower triangular, yeah. Okay. So it's true, yeah. You just check that if you have, let's say, A1, A2 up to AN diagonal matrix, diagonal one, and then you multiply that matrix with the upper triangular, let's say a lower, yeah, or a lower one. The entry that you will have, let's say, over here, this entry, this is just a multiplication of all of the diagonal, yeah. So the structure of the product will not change. The structure will not change. What about this? 23?
22 false. What's a permutation matrix?
Itu yang one. Permutasi one.
Yeah, permutation matrix is diagonal matrix, identity matrix, but then you switch the row and column of it.
Alah.
Switch the row and column and become a permutation matrix. Yeah, let's say you have 1, 1, 1. This is 0, 0. Yeah, this is diagonal, right? Identity, sorry, this is identity. Permutation means you switch the row, let's say from 1 with 2, you switch. So it becomes 0, 1, 0, 1, 0, 0, 0, 0, 1. Yeah, this is a permutation matrix. Yeah.
True.
So the answer is true. Yeah. Answer is true. Okay. One thing that I want you to remember is that when you switch the row of a matrix, eigenvalue. Do you know what's eigenvalue of a matrix? Okay, eigenvalue does not change. Okay, determinant stays the same also. Yeah, determinant stays the same, which is why also the inverse is also never change. The inverse of identity is itself, right? So also the same with the permutation matrix. So the answer is true. Yeah, in fact,
Aku masih bingung sih.
Hmm?
Bisa sama. Kalau P-nya sama dengan P inverse. Aku masih bingung sih.
Hah?
Aku masih bingung sih.
oh,
How can it be the same?
how it can be the same? Okay, now let us multiply them. 0, 1, 0. You multiply them, what do you get? Zero, 1, 0. So I get 1. Okay, and then this one 0, 0, 0. Okay, the third one, this one 0, 0, also 0. Okay, now the second row. Start with the second row. 1, 0, 0. Second row with the second column, 1. This is 0. And again, you will have this identity. Yeah. So you multiply permutation with itself, it becomes identity. So that's the inverse itself. Yeah.
Oh,
Okay, let us define what is an inverse of a matrix. How do you define an inverse of a matrix? How do you define them?
Kan baru diajarin sama itu loh.
So you say like this, yeah.
Mana
Let-
foto? Iya.
Let A
Itu bagian
is
dong.
a
Bagian
square
dong.
matrix.
Bagian tutup.
Let's say A is a square matrix. Okay. Then B is an inverse of A. If and only if A times B is equal to identity and B times A is equal to identity. So that is inverse. I'm saying about definition, yeah. So the answer to my question just now is not about how to get the inverse. No. It's about the definition. Okay, let's move on. We spent 15 minutes already only on this. We begin with the topic of solving linear system of equation. Do you know what is linear equation means? Do you remember if we have a statics problem? Yeah, let's say you have this problem. This is f1, this is f2, mg. How many equations you can make from this? Let's say we know what's mg. Mg is 100, and then this is a1, and this is a2. The first equation,
Sigma Fy, Sigma Fx, Fy.
this is point P. Sigma fy equal to 0. Yeah. So you have mg minus f1 minus f2 equal to 0. And then sigma moment at P equal to 0 at this, yeah. And then we have minus mg a1 plus f2 a1 plus a2 equal to 0. So we have two equations, yeah. The first one and the second one. Let me write it over there with black color. Let me use black color. So you have mg like this, and then mga1 minus this f2 plus a. Okay, this is what we call as linear equation. We have two equations, and then we have two unknowns. That's the linear equation. What do we want to find from here? We want to get what? What's our purpose here? What do we want to compute from here? We know mg already, and we know a1, a2.
Oh, F.
What is f1 and f2?
Reaction.
They are reaction forces, yeah, unknown, and we want to compute that. Yeah, this is statics problem. And so if we write this in a matrix format, how do we get it?
Not all the A1.
So you put the variables here, yeah, the unknowns here. Then this will be the constant that you multiplied with f1 and f2. The first equation, mg minus f1 minus f2 equal to 0. So we have minus f1, minus 1 times f1, minus 1 times f2 equal to mg, minus mg, yeah. Second equation, f2, a2, a1. So f1, what do we have with f1? This is 0, yeah. So in here A1 plus A2, and this is mg A1. You got it? Yes. So this is our linear equation. And that's exactly what you see here, yeah. So x1, x2, x3, they are the variables that we want to know. Okay? A11, A12, these are known constant, which are the entry of the matrix. Yeah, they are the entry of the matrix. Okay? Any problem up to this point? A11, A12, here, yeah. So matrix A we define here as a 3 by 3 matrix. And the B1, B2, B3, these are the constant we have on the right side. This is known, okay? Known variable over there. F1, F2 correspond to x1, x2, and x3 here. Linear equation, is it limited to only 3 by 3 matrix or 3 equation? How many equation you can get into the linear equation? How many? 100 equation can? Yes, as much as the unknown. Okay. So don't limit yourself only 3 by 3. It can be many equations. Okay. So generally, this problem is called AX equal to B problem. And we want to solve this by finding the X. If it is in this format, it is easy, right? Okay, you compute F1, you compute F2, and then substitute back to here, you can compute F1. Yeah. This matrix is in what format? What is the property of this matrix? Is it diagonal, symmetric?
Symmetric.
Square, yes. What kind of matrix is this?
Lower.
Upper triangular matrix. Okay. Upper triangular matrix. So if you have a set of linear equation like this, and then you create the matrix format, one of the way of solving the x1, x2, x3, x4, etc. is that to do what we call as elementary row operation. This elementary row operation is done so that we can get the upper triangular matrix. Yeah, you know, once you get the upper triangular matrix form, you can just compute the last part, the last variable, and then substitute back to the upper part, go back all the way up to the first part. Yeah, you get what I mean? So let's say you have this is a lower triangular, right? This is all 0, and then you have this is A1, A2, A3, En, and this is x1, x2 up to xn. Yeah, sorry. Multiply by x1 up to xn, and this is equal to b1 up to bn. Okay. How do we get xn here? Xn is equal to bn divided by bn. Okay. Yeah. So for the last equation that here, because it's all 0, it's just an xn equal to bn. So you get xn by dividing bn and an. Yeah, and then you substitute back to the equation for an minus 1 all the way to a1. That's the plan. Okay. So the plan is that you will create a an upper triangular matrix. Yeah, by doing the elementary row operation. So what we can do in elementary row operation, we can switch rows, switching the rows, not switching column. Yeah, this is switching rows, or multiply a row by a number or then add, subtract a multiple of one row by another row. Okay, let's see an example. An example is like this. So you see this matrix is an augmented one, already augmented. Yeah, let me write it.
Just
So I will write here. Okay, before you do the elementary row operation, you have to augment the matrix. Previously, you have AX equal to B, yeah? And then you augment the matrix into, this is A and this is B. Yeah, after that, you do the elementary row operation to this matrix. This is not multiplication, yeah? No. We only add a column here. For example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is x1, x2, and this is equal to, let's say, 10, 11, 12. Yeah, easy number, yeah? So before you do the row operation, what you do is augmented this matrix into 1, 2, 3, 10. This is 4. This is 11. Then 7, 8, 9, 12. Okay? Let's say you switch the row. Switch row 1 and row 2. What do we get?
4, 5, 6.
Switch row 1, 2. Then we have 4, 5, 6, 11, 1, 2, 3, 10. It remains the same. Okay, now you understand, yeah, how to do it. Okay, so these are some of the comments. If let's say you find out that A11 is 0. If A11 is 0, you switch row 1 with a row that is having non-zero for the first column. Yeah, because we want to make the upper triangular matrix like this, we want the diagonal to be non-zero. That's the best option. Okay, the best option is that we want to make the diagonal to be non-zero. Okay, any problem on this concept? Let's see an example. So we want to eliminate the first element in the second row. Yeah, because we want to make finally we want to make this non-zero, and then this one, and this one 0. Yeah.
Oh, okay.
So we have to make this become 0. How do we do that? We do that by doing this. Yeah. Row 2 minus A21 divided by A11 times R1. You do that for all of the entry. Okay, let's say we do this here, yeah. Let's do it here. If we want to make this entry to be 0 by doing something with the row number 1, what do? We can do 4 minus 1 times 4. Am I correct?
Yeah.
Yeah, let us do that.
One.
Yeah, row number 1 you multiply by 4.
Minus.
We only do it to the second row, yeah. Row number 1 we do nothing.
Okay.
Okay, so we do operation by row 2 minus
Row 1.
4 times row 1. Okay, so the first row remain the same, 1, 2, 3, 10. Second row becomes
0.
this is 0. 5 minus
8 minus 3.
minus 3, 6 minus 12, minus 6, 11 minus 40, minus 29. Easy? Easy, right? Huh? Yeah. What about row number 3? Hmm? You do the same thing? Yeah. We do the same thing, but then it is not 4 times row 1, yeah? It is 7 times row 1. Okay. What do you mean? Yeah, we want to eliminate second row element number 1 and the third row element number 1. So the reference, it has to be the first row.
But does it have to be the first row?
Yes. Before you finish, it's yes. Why? Because we want to keep row 1 the same, but then we change the remaining row, yeah? What if you multiply with row number 2? Row number 2 change, right? We cannot do that. Okay.
So why do we want to make that number?
Just now I explained that already. You didn't listen, ah.
I listen, but I don't understand.
Okay. Let me just create a tree.
You do the division without regular another.
Let's say we have A11, A12, A13. This is 0, yeah? Keep row 1 the same, yeah? And then let me say this is A2. This is A22 bar lah. Okay, this is A23 bar because that's different. And then in here we have A33 bar. Okay, I think this is going to take quite long to finish it. Okay, and then we have X1, X2, X3. Okay, let's say this is already changes to another number, yeah? So what's the last equation says?
Yeah, X3 equals over 8.
No, the last equation says A33 X3 equal to B3 bar. So X3 is okay. Yeah, what about X2? Because you know already X3, right? So you can compute X2.
Oh, okay.
Back substitute to here.
Oh.
Okay. So that's the point of making lower triangular matrix. Sorry, upper triangular matrix. Yeah. Agree with me? Okay. You can also actually you can do it step by step. Yeah. Let's say you are so lazy, I will just do one row at a time. Okay. Just do this, and then you don't want to do anything with row number 3 yet. Then you write this. I'll do it later. Now you want to finish it using row 2. You can do that. You can, yeah, if you are so lazy. If you are diligent, clever, you do it one time.
I know.
You know? You know what I mean? So let us do it in one go, yeah? Do it in one go. Are you lazy or not?
Yes.
I don't want to study with you then. No use wasting my time. Okay, so what would you have here? 0. So we will do R3 minus 7 of row 1. This is 0. 8 minus 14 is minus 6. 9 minus 21, and then 12 minus 70 minus 58. Okay, that's our first step. Okay, and then the third step, we eliminate again this. So how do we do that? Row 3 minus, are we doing it with row 1 or row 2? Why with row 2?
It's
Huh?
easier.
Why can't we do it with row 1?
The zero is gonna.
Yeah, if you do it with row number 1, this part will not become 0.
Yeah.
Now this time you are diligent but not clever enough. Yeah, you have to see, you have to do it with row number 2. Yeah, in this case. Okay, row 3, and then is it minus or plus? Minus 2 row 2 lah.
Yeah.
Yeah, because this is minus. Okay,
Kali minus.
you multiply with minus and then
Get some. Get
Okay.
6.
so you have 1, 2, 3, 10, and then 0. What about this? 0.
0.
This is 0.
Uh,
Minus 12
Zero.
minus 2 times
0.
0 again. Yeah.
Yeah.
Okay. What about this?
0.
No.
0. 0. Yeah.
0 again.
0.
Okay. Yeah, this is a special matrix. Yeah. Let us check again. Is this correct? 6. Yeah, this is twice of it, right?
Yeah.
Correct. So because this is twice of it, this is an example of non-linear independence matrix. Okay, not linear independence. So you have a free choice of the last. Yeah. So that means the equation becomes uh, 1, 2, 3, 0 minus 3 minus 6, 0, 0, 0. And that becomes 10 minus 29 is 0.
Oh, actually, or
Yeah, because this is 0 times x3 equal to 0.
Yeah.
Yeah, x3 can be, no, x3 can be anything.
Huh?
Let's say you have 0
Oh, yes.
multiplied by x3 equal to 0. What we can put here?
Any
Any number. Okay, that's free choice for you. Yeah. Yeah. So you just, let's say, define, let's say x3 is equal to 1. Yeah. You put x3 equal to 1, and then from equation number 2 here, you have minus 3 x2, and then minus 6 times 1 equal to minus 29. What is x2 there?
9.66.
Huh? Minus 29 plus 6.
Oh wait.
Yeah, 23 over 3. 7, 2 over 3. 7.6 lah. Okay, 7.6. And then you go with the first one, you get the x1. Okay. So what if we change x1 into, let's say, 2? x2 will change, right? x1 will change, right? So that means we have more than one solution. Is this correct or not? Huh? Yes. If you find out a system like this, then you will have infinitely many solutions. The solution is not unique. But it doesn't mean the answer is wrong. Answer is correct, but then it it's not unique, and we will find those here. Okay, and you have to know how to work with that. Yeah. Okay, because the original matrix that we have here, that means this is not linear independence, not full rank. Yeah. Okay, let's move on. So that's the ideal case. If you have an ideal case like this, then the solution will be unique. Only one solution that you can get. But if it is like that, then you will have multiple solutions, infinitely many solutions. Okay. If let's say you have a problem like this, yeah, 0 times x3 equal to non-zero number. So let's say for the sake of example, yeah, just for the example, if I change this number into a different number, yeah, let's say 13, then I will have 0 here and non-zero here, yeah, correct?
Yes.
So I will have, instead of this, I will have a number that says 0 times x3, which is, let's say, with 3 bar. And in this case, there is no solution, and that is possible to happen. It is possible, and you need to know also how to deal with that, how to see whether a linear system equation cannot have solution. You have to be able to know that, and for sure it will arrive in examination, in homework, PCST, and anything. Yeah. So there are 3 cases. One is unique solution, no solution, and infinite number of solutions. There are 3 cases. Okay. Any question so far? Unique solution means your matrix have inverse. Yeah. If your matrix has no inverse or singular, then it can either this one or that one. Either many solution or no solution at all. Yeah, so the 2 cases below here only for non-singular matrix. Sorry, for singular matrix. 2 cases below is only for singular matrix. Yeah. What is the determinant of a singular matrix? Determinant of a singular matrix? Yeah, it has no inverse. What's the determinant? 0. Yeah, you get the inverse by doing 1 over determinant, right? If the determinant is 0, then we cannot define the inverse. Okay. An example which you can study later, yeah. This is an example of non-singular matrix. Okay, non-singular matrix because we have a proper upper triangular matrix. This is upper triangular matrix. Okay, exercise. You solve this now. Yeah. While you are working with that, you can ask me whether if you have problem with this. Quite fundamental, this one. And any question so far?
No,
Not yet.
Gila.
Jawabannya udah pasti. No.
Okay, why don't I do that? Brian and Sean, you do the first one.
Yeah.
Yeah, Radit, Jarvis, you do the second one. Rafi, Dylan, you do the third one. Sean, Michael, you do the fourth one. So that we can get quickly. The first one, non-singular, unique solution. This one,
No.
infinitely many solution. This one also infinitely many solution. This one has no solution.
How would you know?
I said that already.
Because
You will be able to see later that this one have no solution.
Oh, iya. Oke. Pakai kantong. Kamu bikin nol kan? Bawahnya jadi 22.
Okay, Sean, 1 2 1 2 2 4 3 5 and 1 2 3 0 0 what? Okay, 0 0 minus 1 and then 0 times x2 equal to has no solution. Okay, yes, no solution. Okay, correct. Easy, right?
Yes.
Only 2 by 2, easy. How about you?
Tapi aku kalau misalnya nulis yang atas yang ini dari X1 ya
Imagine dulu.
You cannot get the x1.
Jadi apa? Unique solution.
X2
kalau misalnya ada
non-existent.
solution.
Ah,
Kalau misalnya ada solution gitu.
if there is a solution, then you use the top equation to get the x1.
Ini kali ini sama dengan
Infinite amount of solution.
Yeah, because you know x2 already, right?
1 times 2.
No. 1 times x1 plus 2 times x2 equal to 3.
Oh, oke. Oh, karena ya.
Yeah, that's how we read the equation.
Number 3 has no.
Number 3, infinitely many solution. That means when you arrive at x2, you are free to choose x2. Is that correct?
Can we choose x2 to be 0, sir?
You can.
We can.
X2-nya apa?
Let's say x2 0. What about x1? It has to be non-zero. Non-zero, right? x1?
Yes, it's gonna be x1 equal to 2.
Yeah. What about if x1 x2 equal to 1?
x2 equal to 1, it's gonna be no solution. Because 0 times what's the way? It's gonna be 0 times x equal to 1.
Your case, what's the answer?
Dari X squared.
Hah?
Kita ke situ ini. Lu kali ini dulu nih. Sorry.
Yeah, and then what's the answer? Not yet.
Kan lu tulis gini nih. 1 4 0 0 sama dengan kali x1 x2 dengan 2 sama.
Jonathan, got it already?
Misalnya kita belajar dari bawah dulu nih. Kali ini.
So how's the answer going?
Kita tahu kan di bawah sini. Ini kali ini. Ini kalau triangular. Jadi kalau di kalian cuma sisa ini aja harusnya. Jadi harusnya sisa ini kan 0. Harusnya ini 0
Yeah, I think so.
kali x1.
Yeah.
Kan udah 0 ya, nggak banyak bisa. Ditambah 0 kali x2 itu sama dengan 0.
You arrive at the equation, right? So you have 0 times x2 equal to 0, right? Yes. So x2 can be anything. You can choose 1, 2, 3, 1.1, 1.3, minus 1, minus 3, doesn't matter. As long as it is real number, you can have that. Okay. Once you choose x2, you compute what is x1.
X1 kan tahu nih.
You just substitute back to here, right?
Yeah.
1 times x1 plus 4 times x2 equal to 0. Okay?
Nah kalau misalnya x apa namanya? Ini misalnya ini ada angka, Yang kan berarti 1 kali, misalnya di angka 1 kali X2 sama dengan 0 kan. Berarti X2 sama dengan
What is x1 there?
minus 4.
Minus 4. So x2 1,
X2 is
x
bukan. Kalau X2 nya bukan sama dengan.
x1 minus 4. Okay.
Kalau misalnya ini 1
kiri ya.
Okay. Let us discuss this here. For number 1, your augmented equation is
ada angka
5,
guys.
6.
Kan, ini punya lu jawabannya apa? Oh, bukan sorry. Kalau ini.
So we eliminate this by doing what? Row 2 minus 3 times row 1, yeah? Row 2 minus 3 row 1. And then we have 1, 2, 5.
0.
This is 0. 4 minus 6. 6 minus 15 minus 9, yeah? So that means you can have the equation minus 2 x2 equal to minus 9. And then the answer is that x2 equal to 4.5.
Ya. Angka
To get the x1, you use this equation. X1 plus 2x2 equal to 5. Okay.
10 artinya x1 is negative 5.
So x1 equal to 5 minus 2x2
Enggak. Makasih. Ini kan
equal to 5 minus 9, 4.
4.
So this minus 4. So the result okay. Get it ya? Any problem on this? Clear?
Jangan nanya Sir. Itu bukan harusnya min 2 plus x2. Enggak dong.
tanya aja dulu.
Bikin bingung jangan.
Apa?
4 minus 3 times 2. Minus 3 times 2 is minus 6, right?
Bukan itu Sir.
What?
Kayak jangan bingung tadi.
Jangan tanyain dulu.
Why 12? That one 12?
Agak kesana. Tadi dia kata soalnya.
It was not here. When you explain.
Okay. No problem on this, Michael?
Oke.
Clear ya? No, okay, Johan? Yeah. Second problem. The second problem has infinitely many solutions. So 1, 4, 0, 4, 16, 0. What do you observe here? The row and the column of the matrix. The second row is 4 times the first row, yeah. Also, the second column is the 4 times the first column.
It's gonna be.
Dia pasti nanya.
Yeah, it is not linear independent.
It's gonna be. Yeah.
0, 0.
Okay. So what do we do here? We just do row 2 minus 4 times row 1, yeah. Row 2 minus 4 times row 1. So 1, 4, and 0. This is 0. Everything is 0. So that means 0 times x2 equal to 0. x2 free to choose. Free to choose. Yeah, let's say x2 you choose it to be 1. What about x1? Yeah, so x1 plus 4 equal to 0. So x1 is minus 4, x2 minus 4. So the answer in here minus 4 and then 1. Okay.
For the non-linear value, or can I just say it's the
Say it again.
non-linear
Yeah.
value, or
You say first it is free to choose, then I'm choosing a value. Okay.
ini
exam, we cannot just stop until
No, not up to here. You choose this.
and then go.
Yeah.
So any answer after that can be correct and we calculate correctly.
Yeah, in fact, the correct answer is this. Yeah, x2 and x1.
X1 equals to
You answer this by x1, x2 is equal to an alpha multiplied by -4, 1. This alpha is a constant, real number constant. You just check. Alpha can be any number, and the result is still 0. Okay. The third one. The third one, 1, 4, 2, 4. The same, yeah. R2 minus 4, R1. This is 0,
0, 0.
0, and then what's in here? 0. But this is 2, yeah, not 0 there. So let's say x1, x2 is 1, then x1 you get it by equal to 2.
Huh?
Yeah, so x1 is 2 minus 4x2, which is -2. Yeah, so the result in here -2 and 1. For this case, we cannot say this is equal to alpha times -2 and 1. No, we cannot do that. We cannot, yeah.
Oh, because it's just a
Yeah, because
definite number.
the right hand side is 0.
Yeah.
It's non-zero, yeah. We cannot say this. But what we can say is this. These are the same matrix, right? Yeah. So the answer, the proper answer to this is that x1, x2 is equal to -2, 1 plus alpha times that one, -4 and 1. So these are the solution. I'm saying just now, right? It has infinitely many solutions, which is this. Alpha can be any number. Yeah. This one also, it has infinitely many solutions, which is this. This is just one of the solutions. What are the other solutions? These are one. Alpha can be any real number. Okay.
kalau nomor 2 sama nomor 3 terus sama metriknya sama 1 4.
Say it again. I don't understand. You know it is free to choose after you do the elementary row operation and get all the 0. After that, you know it is free to choose. Yeah. Oh, I got what you mean. Yeah. So if you find out this equation and then the matrix is not full rank or singular, then you have to find out what is the null space. This is called the null space. Yeah. You find out the solution when it is 0, 0. That's correct. Yeah. Find the solution when it is 0, 0. Okay. 0, 0. This one. This, yeah. You don't know where to look just now. You look here. If the matrix is singular, you want to find out the solution x1, x2. The first step is that you find out what is x1, x2 that makes the solution to be 0 in here. Okay? Like this. And after that, you begin to compute solution x1 and x2 for the non-zero one. After that, you do this.
Also, if we got that one.
Yeah, that's the complete solution. Well, normally what you will be asked is that whether it is has no solution, it has infinitely many solution, or is it unique and what's the value. I think it's in the homework like that, but in exam I think you will find something like this. Yeah, you have to be able to do that. Any question? The
But
last
but
yeah,
the number that we choose need to be the same for the both calculation.
yeah, what is
The chosen one. Like
chosen
we choose
one?
one on the 0, 0, we need to choose on 2. Right?
No need.
Can be
In
different.
it can be different.
It's okay.
It's okay. It's okay. Let's say I choose here x1 to be 1, x2 to be 2, right?
Yeah.
In there I choose x2 to be 10. It's fine.
Oh.
You will get different x1. It's fine.
Beda tapi rasionya sama kan?
Ratio the same. The ratio determined by this equation. Okay. From 1 to 10, how do you do that? 1 plus 9, right? So the above you have to be plus 9 times minus 4. Minus 2 minus 36. So if it is 10, then this is minus 38. Understand? Or no? No, you don't understand. Okay. The solution here says that my x1, x2 is minus 2, 1 plus alpha minus 4 and 1. If the solution is this, what's alpha? If I choose this to be my solution, what's alpha? What is the alpha in there? 0. Why is so slow? 0, man. we don't need this, right? I'm saying that if the solution is minus 2 and 1, then alpha has to be 0. Okay? If my solution is let's say if the x2 is 10, what will be the x1?
Minus 2.
Yeah, 10 is 1 plus 9, right?
Oh yeah.
Yeah, is 1 plus 9. So it means alpha is equal to 9. 1 plus alpha equal to 10. What is alpha? 9. So use 9 here, use there. So the new x1 is equal to minus 2 plus 9 times minus 4, which is minus 38. So now you use MATLAB. x1 is this, x2 is this. Do you get 2 and 8 also? Now you do it. Is it clear? Is it too fast? Really?
Yes, perfectly. Or if the x1, x2 minus 2 minus 1 alpha, if we change the final answer, karena sih waktu itu kalau masuk ke
Brian, is it correct? Minus 38 and 10.
Tambah. Nah, di atasnya alpha jadi 9.
Correct, yeah. So it shows that we choose different alpha for it.
Ya, X1, X2 nya ganti itu.
Oh, okay. Changes.
Nah, di MATLAB-nya ya dikali aja. Nah, matrix kan.
Oh, C hasilnya ya soalnya.
Ya. Yaitu yang X. Sini ya.
X1, X2.
Itu di counter.
Oh, oke. Ngerti.
Itu mana dari
Michael, is this okay? Or not okay? Brian, done already? Why take it so long? Ah,
Abang gigi.
Enggak ada dia. Kita ngapain? Enggak di PS5 ya. Di method yang 2 sama 3 NAM, yang 4 infinite command.
what are you doing? You are comparing the inverse or what?
Ya, I'm searching for X.
If you find using inverse, you cannot find the inverse on it. You cannot find using inverse or M-divide,
I try to A backlash B.
and I cannot do that.
Okay.
Cannot. Yeah, true. Yeah, you cannot do that. If it is singular matrix, we cannot the backslash. Backslash only for non-square matrix, but it has to be full row rank. Okay, the backslash, yeah. Non-square matrix work for that, work for the non-square matrix, but you have to be full row rank. But if it is singular, you cannot do that. Yeah.
Oh iya.
Right. The next one that we want to say, this is just the thing that we just discussed, yeah. An illustration, what does it mean by unique solution, infinite number of solution, and no solution at all? Yeah, just a visual example. Okay. To review, this is a concept question. Number 24, what's the answer?
An n times n system of equation have at most one unique solution.
You think false? It's true, yeah. The unique solution is only one.
Bisa satu dari dua. And only have one solution. Uniquenya cuma bisa satu.
The unique solution can only be one, yeah.
Oh,
One solution means the whole thing is one solution. Yeah, not x1 is one, x2 is one, then you have two unique solution. No, not like that, yeah. This is one solution. And this is unique for number one that we discussed, that you did just now. That's unique solution. Yeah, number 25, true or false?
Has more than one solution, then it must have infinitely many solutions.
It's true, yeah. We show it here, yeah. If it is more than one, it is infinite. Okay. How do you see whether it is unique or not? We just discussed. No need to compute.
Yang pertama no, not unique. Karena no.
Ya, unique.
Karena
Karena 3 kalinya.
Yeah, because the row and column is 3 times, yeah. What about this?
Satu solusi. Kalau 2 kali ada A. Kalau dikali 2 ada A. No.
oh ini
Ada satu jawaban. Yang kedua harusnya ada satu jawaban. Enggak. Ada 0 ya sebelah. Unique.
The answer is not unique. For both, answer is not unique. Okay, let me tell you how to see that. The first thing that you can do is that to check whether the rows and columns are multiplicative of one another. The second thing is that you try to find whether you will have non-zero x for the 0 on the right side. If it is like this, and then the answer here is non-zero, then it means your matrix is singular. Okay?
Okay.
Determinant is 0. You check using MATLAB, determinant is 0. The easy way to see this is that you just sum the columns to the right. 2 plus minus 1 plus minus 1, 0, right? You add this, becomes 0. You add this, becomes 0. So the x that satisfies is 1, 1, 1. You put 1 in here, 1 in here, 1 in here, it will satisfy the equation. Okay? So what I mean is that if you can find non-zero x which satisfy this, yeah, if you can find non-zero x which satisfy ax equal to 0, then it means a singular. A singular means you will have infinitely more than one solution if it exists. Yeah. Okay.
Oh, belakangnya. Oh, itu.
It can be infinite solution or it has no solution. This one is infinite, but this one, let us see whether it is infinite or not. We'll see. Where is the eraser here?
Kayak tadi.
Particularly number 3, let us check 2 minus 1 minus 1 0 1 2. Okay, what is the first step in here to do the elementary row operation?
Row 0 the third row. Row 1.
It is 0 already, right?
Ada 0 nggak? Langsung loncat aja.
So we can do the third row with the first one, yeah. Okay. So we do R3 what? Plus
R1.
plus R1.
Yeah.
That's it. So it becomes this is minus 2, this is 2, and 4, yeah. Okay. What do we do here?
Times 2.
R3 plus 2
times
R2, yeah.
Yeah.
Okay. So we have 2 minus 1 minus 1 0 1 minus 1 minus 2, and then
0.
this is 0.
0.
2, this is 0 also.
0.
Huh?
Yes,
0 also.
Yeah.
Okay.
Yes,
So in this case,
unik juga lah. Mau kali ekspor lagi.
minus 2 plus
3 sama dengan 3 begini.
2. Yeah, this is just minus 1 of this, yeah. Minus 1 of that.
Kalau kali X3 sama dengan 0.
Alright, so we have 0 times x3 equal to 0. That means x3 is free, yeah.
Iya, bebas. 0 times x3 sama dengan 0, benar. Bukan sama dengan 3 dong. Karena kita ngambilnya nomor yang di ujung.
Meanwhile, what about second one? X2 minus x3 to minus 2. So x2 is minus 2, yeah.
Iya, yang berarti unik.
Oh, it's not unique.
Gak unik.
It's not unique.
Wait,
Because
the unique solution is the one that have the one answer only.
yeah, only one answer without the alpha.
Ini kita 0 sama infinity.
Okay, correct ya. This is x2 is minus 2 ya, correct? Yeah. And then what about x1? 2x1 minus x2 minus x3 is equal to 1. So 2x1 plus 2 minus 0 equal to 1. Okay, so x1 is equal to minus 1. Minus half ya. It's minus half. So that means the final answer is minus half, minus 2. I choose x3 to be 0, and then plus alpha. Okay, that's the whole solution. Okay.
Langsung titik aja kan? Langsung alpha.
Yeah, alpha time. Yeah.
Why it's one? The solution of the second answer.
Yeah, solution of this. Why cannot what? In here? No, we cannot have all 0. Trivial solution do not apply. Yeah, that is trivial solution.
Tadi yang pertama nggak unik.
No, the first one is not unique also ya. Not unique.
Dari mana nih?
It's infinitely many.
Kan no.
Okay. Let's move on. This one is just discussing about the inverse. Yeah. You know that when we have the problem ax equal to b, we can compute x by computing the inverse of a. That's one of the idea like you did just now with MATLAB ya Raffi. You compute inverse. Yeah, inverse. If we use it to compute the eigenvalue, that is one of the best thing in using the inverse. It says here. Because if let's say you have a set of vectors x, a set of vector b, you have to do how many elementary row operation? N times elementary row operation. However, if you use inverse, then it is just in one go ya. You compute the inverse for one time, and then you can get the whole solution. However, if it is just one time of elementary row operation, it says here that Gaussian elimination is more efficient than computing the the inverse of the matrix. Okay, yeah, before we go into the vector spaces, let us discuss a bit on this problem. Upper triangular matrix with 0 on the diagonal. Okay, what is u square? If we square it, what is u13? Yeah, u13 is the third column, first row.
Oh, u square of 13 u13 square gitu.
Yeah.
Notationnya gitu.
Yeah, you just
Row column.
you just do this. You multiply. What do we have? All 0. If you want to get this part, yeah, the u13 is over here, yeah. You get u13 by doing this and that, yeah. So u13 is you multiply that with that, so it only two entries, yeah. So it is 2, The answer here is 2. Answer is 2 here.
Still confused.
You got it? Yeah.
Apa one yang paling bawah?
Hah?
Itu panjang semua.
Sorry.
Zero.
This is 0 ya. I made a mistake. Why don't you remind me ya?
Dia udah cap-cap tadi.
Okay.
Dia udah cap-cap tadi.
So the answer is 1 ya. Yeah, this is 0. 0 times 1, 0. 1 times 1 is 1. 1 times 0 is 0. So answer is 1. Yeah. Let's move on to number 42. This one. I think you think about it later lah. This one. This one.
Which for which values of alpha?
For which value alpha have no solution? For which value alpha will the system have no solution? This is quite important, so I want to discuss this. Still have time? Yeah.
Nambah gini gimana? Oh, 2 minus 2.
Tadi apa? Kalau 1 kali kolom
Dia
2.
ngasih.
Kalau 1 kali kolom 3 pangkat 2.
Dia
Soal sebelumnya. Sir,
Yeah.
the last question ask us to calculate row 1 times column 3 and then square it.
No. This is already square.
Itu kan A kali A itu.
This is u square already. And then we are asked what is the first row element and third column,
Okay.
yeah, of that product. Okay, if we have this problem, then we convert into the matrix equation first. 2 minus 6 alpha, and in there 6 alpha minus 2. What is this? 3 and 3. So what we can see here is that from here to here depends on how big alpha is, yeah. 3 and 3. So if you want the system to have a solution, then this and that one, it has to be the same. Minus 6, right? Yeah.
You want to have a solution.
Yeah, so let's say from 2 to 6 we multiply by 1 3, yeah, 1/3. So from here to here 1/3 also, right? Yeah. So alpha in there is 1/3. We can have solution. We can have a solution if alpha is 1/3.
Kalau bentuknya sama, cannot.
Can. We can have a solution if alpha is 1/3.
But we said earlier, if we minus it, 2 minus 2 is equal to 0.
Yeah, you see the ratio between this one and that one is 1, right?
Yeah.
Okay. So because this is most likely will be singular matrix. So alpha in here must be 1/3. We want the top row to be the same with the bottom row. The same. Let's say if it is 1/3, this is 2 and this is minus 2. And this is also 2 and minus 2. Then we will have a solution. We have a solution in this. If it is not 1/3, let's say 1. Let's say 1. If alpha is 1, then we have a 2 like this. what do we get? 6. I think better if we just keep the alpha in there and then do the elementary row operation. Okay, do 2 minus 6 alpha, 6 alpha minus 2. Let's do elementary row operation. To eliminate this, we will multiply with
3 alpha.
Huh?
Minus 3 alpha.
6 alpha minus 3 alpha.
3 alpha.
So R3 minus R2 minus R1 times 3 alpha.
Yeah.
Is it 0?
0.
0 again. This one?
Minus 6 alpha. 0.
Kok bisa 0 sih?
3 kurang 9 alpha.
Is it 0 here?
Second one.
6
Oh,
times
berarti.
3 alpha
Minus 2 minus
Oh iya.
6 alpha times
minus
3
6 alpha.
Yeah.
Like this, right?
Iya.
Yes. Ya benar.
What does it become?
Minus 2 minus 2 plus 18 alpha square.
Min
6 alpha.
kenapa kali 3 alpha jadi ya 18.
Ya, 18 alpha square.
Correct ya? Minus 2 plus 18 alpha. Minus 2 plus 18 alpha. And this one?
Isn't
18
the
alpha square.
Alpha square.
Yeah.
And this one?
6 alpha.
Tambah 9 alpha ya. Minus 9
Uh,
alpha. 3 minus
3 minus 9 alpha.
Enggak sulit.
It's 9 alpha. So if you want to have a solution, then this and that one has to be the same. They have to be the same.
So if the top row and the bottom row is the same, then it will have a solution.
Yep.
Okay. Nanti
Artinya kalau misalnya nggak 1/3 gitu. No
Say that
solution.
again.
If alpha isn't 1/3 plus minus 1/3.
kalau misalnya kasih alpha yang
Berarti no solution.
Yeah. If it is not 1/3, it will have no solution. If it is 1/3 here, what do we have here? 18 times 1/3 square is 1/9, yeah. This is minus 2 plus
Plus 2.
plus 2, which is 0, yeah. So in here 3 minus 9 times 1/3, which is 0 also, yeah. 0. So 0, x2 0, x2 is free to choose.
So no,
Yeah,
it's not the solution.
there is a solution.
No, I mean the answer.
Yeah.
Oh, the answer.
Okay.
Answer.
So the answer is that it will have no solution if alpha is not plus minus 1/3. So it's D.
Oh, it's D.
If it is 1/3, it has solution. 1/3 has solution. Plus minus 1/3 has solution. Yeah.
None of this is never the answer.
So the answer in here is D.
Tapi katanya kalau misalnya D,
It has no solution. No. The question asks you for which value of alpha that the system will have no solution.
Ada sekali.
Iya.
Ada kayak.
Oh iya.
Di mimpi gua.
Okay.
Kalau nggak 1/3, I think no solution.
Jadi 41 ya?
Plus minus 1/3.
Tadi.
Well, let us check if alpha is 1. Let's say. If alpha is 1.
Minus 2 plus 18, 16. 16.
Sudah ada
Do we have?
solution.
Do we have solution on it?
Minus 2 plus 18.
But if it's one?
1 square kan
If it is 1, do we have solution?
If the alpha is 1, The alpha is 1. Yes.
Yeah. Terus ada solution.
Ada solution.
Oh, we have solution.
Yeah, so none of this.
Oh, none of this then.
What? Harusnya? Hah?
If alpha is 1, in here becomes 16,
Ya.
and in here becomes
Minus
minus 6.
minus 6.
Okay.
This 16x2 equals to minus 6.
Ada solusi kan kalau gitu?
Iya.
Kalau alfanya 1.
Oh yeah, that's correct.
No, yeah,
sorry about that.
that's the correct answer because it's asking us which one will give no solution, right?
Yeah.
So none of this.
So none of this, yeah.
Yeah, none of
Minus 1/3 will give you solution. This one give you, yeah. Okay, none of this. Sorry about that. So if alpha, yeah, let me say this correctly. If alpha is 1/3, you will be the matrix will become singular matrix. Wait, singular matrix. If alpha is 1, that's minus 6, 6 minus 2. 2 minus 6. Oh yeah, 2 to 6 is times 3. 6 minus 6 to 2 is not, yeah. Okay. So this is perfectly non-singular matrix.
Sama dengan kakak.
Okay.
Ya kali ya sama dengan this.
Yeah, I made a mistake with this. This is a non-singular matrix. Can you check with MATLAB? Does it have an inverse? This one?
Kayaknya minus seperti itu.
Yeah, well, minus 1/3 you can have solution.
this.
You can.
No. No, if we use minus 1/3, it becomes 0 times x something equals to a number.
Say that again.
We use minus 1/3, we will get 0 times x equal to some number.
Oh, this minus over here.
Yeah. If it's
Oh,
minus, then
it-
plus, right?
Over here is 0, and then this is plus, right?
Yeah, plus. So minus 1/3. So,
Oh, this one, yeah. Oh, minus
Minus,
1/3,
minus.
yeah.
yeah, that's A. Kalau lu pakai minus sepertiga, lu dapat nanti 0 kali x.
So
sama
this
dengan-
is 6. Yeah, that's
number.
correct. That's correct. So if alpha is minus 1/3, this is
Atau
not.
1/3
It
pangkat
will become 6, yeah.
Iya. Ya kan jadinya 0 times x equals 6 gitu. Berarti no solution. So, yeah.
2 plus 2.
Yeah. The
Yeah.
answer is B, yeah, on this case.
The A.
The alpha is the A
A.
minus 1/3. Sorry, I made a mistake on that.
No, please.
So you check by doing the elementary row operation, get the upper triangular matrix, and check on the last part, yeah.
Iya, tadi kita coba pakai sepertiga. Terus asumsi minus juga awal.
Jadi kalau kayak gini kita coba satu-satu aja, Sir.
No. You are doing this, yeah. So if no solution means you have, and this is some number, okay, then no solution. If it is 0, you have solution but many solutions, okay. And if it is a bar x2 equal to b bar, then this is unique solution.
Oh, kita dapat pertanyaan gini, Sir, maksudnya kita cari yang
Yeah, you have to check with
kita
this.
cobain satu-satu.
No. Cannot
Cobain
work.
aja sampai
Cannot
dapat.
work.
Kalau
You just check on this.
Langsung.
Yeah, you just check on this. You can get the answer.
kalau buat yang no solution itu akhirnya emang di no solution ya. Nggak ada.
Sorry, if there is no solution.
The ending is no solution, right, sir? Not like this one.
Yeah, this one have solution.
No solution, no solution aja.
The ending no solution.
The infinite one, we got x1, x2 equals something plus alpha, right? But
If it
no-
is infinite solution,
yeah.
okay.
If the no solution one is
I will just
no
say
solution.
no solution without any number. Okay.
Okay.
Okay. This one.
Aduh.
Aduh ini 3 by 3.
Okay, if it is unique, you sum the components. Is it infinite or no solution? Can you check using MATLAB whether the matrix singular or not? Find the inverse or just compute the rank of matrix. You put the matrix 1 minus 1 3 1 2 minus 2 3 minus 1 and 5. You check the rank of this in MATLAB. If the rank is 3, then it can have a unique solution.
1 2 minus 2 guys, 3 minus 1 5 sama dengan 4 10 rank A.
What's the rank? 3. Yeah, if the rank is 3, then the answer is either this one or that one or that one.
Or they have a solution.
It will have a unique solution in that case. Okay. Can you compute the inverse multiply by this? Inverse of that matrix multiply by that.
If we can find if it's not singular, we can just inverse and
Yes.
time the.
Yes.
Oh, okay.
First by that matrix.
Multiply by 4, 10, and 14.
Kali. Jadi inverse dari 1.
Inverse of that matrix multiply by 4, 10, 14.
Ngapain pindah gitu?
What do you get?
Inverse dulu. Wait. Do we inverse the right side or the left side?
No, the left side, of course.
The left side. Balik ini. Yang dia bagi A.
Raffi, what you are doing is you do inverse of A, then you multiply with the B.
Kalau A backlash B itu bisa.
Sama.
Sama aja loh.
Sama. What do you get?
273.
2, 7, and 3. So the answer is 12. In that case, ya.
Kalau dia kayak gini, yang di inverse yang depannya bukan belakangnya.
Iya.
Coba aja.
Inspect.
Kalau ditulisnya kayak gini berarti yang di inverse-nya yang si A.
Yeah, that's correct.
Oh, aku pikir di inverse-nya si B.
That's another method of doing it.
Abel. Gue percaya Raffi aja deh kalau buat method.
Okay, this one the same thing. You check whether it has inverse or not. Yeah. If it has inverse, solution unique. If it is not, it can be line, hyperplane, plane, or no solution. And this one is the same with that. Same thing.
This is the same thing.
What about this? For which value it will have infinitely many solutions?
Infinitely.
Yeah.
Oh, ini yang tadi ya.
Yeah, 1/3. It's our answer just now, yeah. Is B over there.
Satu.
Yeah. So next week we will start with the vector space, linear independence,
baca yang
parenthesis,
benar.
etc. Okay, I'll see you again on Tuesday.